Hello and welcome everyone to the last sessions of today's program, focused on good governance and long-term changes of the water resources systems. I'm Ana de Bustos, maybe you have already seen me. I work at SINTEF and working with environmental impacts and effects from hydropower in river and reservoirs and mitigation measures. And today I will be moderating the session with Emmanuel.
Hi everybody, I am Emanuele Quaranta. I work at the Joint Research Center of the European Commission. I will present tomorrow, and I'm happy to be here and to moderate this session with Anna, who is always smiling. Yeah. So we are very happy to be here, and so we now give the floor to the first presenter, Laurence Tissot. So thank you.
Thank you. It's okay for me? No.
I think I can say a few words about you, Laurence Tissot. So she's a researcher engineer for about 15 years in the research and development direction of EDF. And she works with connectivity and stream flow about, among other topics.
Is it okay now? Yes.
I think so,
Yes.
Talk a bit more.
It's okay? For you can hear? No?
Yeah.
Yes. Everybody can hear me, yes? Yeah, okay. Thank you for this introduction. So I will present you multidecadal trends in brown trout population in regulated and unregulated rivers. So the European Red List of freshwater fish mentions that 37% of freshwater fish species are threatened in Europe, and about 11% have declining populations. And multiple causes contribute to this decline, such as habitat degradation, species invasion, water pollution, or overfishing, and all interplaying with the climate change. And we know that the climate change, the global change, is ongoing with effects already observed on aquatic communities. To focus on one type of stream, the headwater streams, they constitute most of the length of hydrographic networks. In France, they are mostly salmonid streams, where the brown trout, Salmotruta, is the dominant species. And this type of streams have mostly the French hydroelectricity power plants, with 80% of French hydroelectricity power plants in this type of streams. But few studies have focused on long-term trends of trout population densities, while including the effect of the presence of hydroelectric power plants. We don't share the presentation, okay. Thank you. So the objective of our study is to identify the observed trends in trout population densities and, in addition, in key environmental drivers of these populations in French headwater streams. So we have a large data set thanks to monitoring of regulated, so regulated is bypass section, so subject to a minimum in-stream flow, and unregulated reaches. And we have monitoring of stream-dwelling brown trout populations, spawning a diversity of geographic area. So you can see, I don't know if it's okay, but we have 4 main geographic area, 3 mountain areas and 1 lowland rivers. And we have also monitoring of environmental variables known as driver of trout population dynamics. There are water temperature, stream flow, current velocity, and habitat suitability. So for more details, this data set. So we have time series between 1990 2020, almost more or less for all data. And for true data, we have 36 stream reaches that are in bypass section or in reaches without hydrological modification. So we can see here in the table that we have a disparity of number of reaches in each cases. So here we can it's the geographic area, the 4 geographic area, and the bypass section and the reaches, the control reaches. So all cases are not balanced for all these situations. But for these 36 reaches, we have quantitative electrofishing, total electrofishing, a 2-pass removal. And we have between 13 to 27 fish samplings on each reach over the period 1994-2020. And trout populations are distinguished in 3 cohorts: the young of the year, the juveniles, and the adults. In terms of environmental data, we have also time series, and we have monitoring on some of the 36 reaches for water temperature, for stream flow, flow velocity, and habitat suitability index. The habitat suitability index is give an idea of the preference for depth, flow velocity, and substrates for juveniles and adult trouts. So we have time series. So we have calculated 3 types of metrics: the median, the 10 percentile, and the 90 percentile values. And each matrix for 5 time scale, so the annual scale and 4 seasons. So we have compute 75 synthetic metrics. The general temporal trends in environmental variables for one and for densities of the 3 trout cohorts were assessed using a meta-analysis framework previously published on data on large rivers. The weighted meta-analysis was performed on each environmental and trout variable using a Mann-Kendall trend statistics, corrected for spatial and temporal autocorrelation, and computed on each time series as effect size. And the meta-analysis, is used to statistically assess if there is a general monotonic upward or downward trends in the variable over time. Without this necessarily being linear. So the idea is that we have a lot of reaches. For each one, we have temporal trends, and we can compute a general shared common trend between all these reaches. This approach does not allow to quantify the role of each environmental variables, nor the relative share of their effect on trout density trend. So it's a trend for each separately environmental variables and trout populations. So in terms of results, here we have the figure of the results. So we can see here the trend mean effect size that reveals the strength and the sign of the general trends. We have each time scale here, so annual, spring, and summer, fall, and winter. In black square, we have the significant upward trends. Significant downward trend are in gray, and when we have no trend, it's in black, in white. So here we have the result for water temperature. And we can see that at the annual scale, we have a significant upward trend here for the median and the high values, and significant downward trends for the low temperature. We can see also a seasonal variability with a significant upward trend in water temperature during summer and fall, and a significant downward trend in winter. For stream flow, surprisingly, for the period 1990-2017, we have few significant trends. We have a lot of trends, white trends, but we have data on an extended period on 1970-2017 for 11 reaches, and here we can see a drastic, significant market decreasing trends over this period, more extended than 1990. For flow velocity and habitat suitability index, You can see the result here. So significant downward trends in flow velocity are more marked than in stream flow. So we can see for the annual scale some downward trend in median and high velocity. And for a habitat suitability index, we can see significant upward trends for juveniles that reveals the preference of lower velocity and depth for juveniles. And finally, for the 3 cohorts of trout, so we have 3 results for trout population. We have the young of the year, the juveniles, and the adults. All which is together, we can see a significant downward trend for adults and non-significant trends for young of the year and juveniles. So here we can see for all the 36 reaches, and we try to quantify this decline in adult trouts, and we calculate the change in the adult trout density between the first 5 years and the last 5 years of each survey, and we can highlight a median value of decline about 25% of trout density. The meta-analysis can allow also to test the differences between geographic areas and between the type of hydrological modification. And we can highlight significant differences in trends between area, so between the geographic context for adults and juveniles, with a decrease in the Pyrenees that we can that is a significant amount different from the other areas. And we don't see a significant difference in trends between bypass section and reaches without hydrological modification. So I remember here the table with the number of reaches. So we have 36 reaches, is a lot, but all cases is not balanced. So we have a lot of Pyrenees reaches. This area which is reveal a significant decline. So in terms of, to sum up our results, we can highlight trends in environmental variables, particularly an increase in annual water temperature with the seasonal trends, different seasonal trends. We cannot see on this period 1990, 2017. We can't see the trends on annual stream flow, but we can reveal clear decrease in flow, in stream flow, annual stream flow for an extended period. So it's very important to know what the temporal windows that we analyze when we look at these trends. And we can see a decrease in annual current velocity. All these results can be made we can make in relation this result with climate change and particularly with the increase of air temperature. So in terms of trout density, we reveal a decrease in adult trout density, and particularly in the Pyrenees, and no differences between bypass section and reaches, reference reaches. And we can relate the trends in environmental factors with the adult trout density, the decrease of adult trout density. But we know that we have other factors that we don't study here, like the increase of disease. So in France and in other countries, we have the proliferative kidney disease that induce mortality on trout population, and that in relation with water temperature. So we know that the disease can a factor that explains the trout density, the decrease of trout density. We also have a decrease of stocking, so maybe it could explain also the decline of adult trouts. And finally, we have an increase of the predation by the otter and the mink, the American mink, that can explain also the decline of adult trout density. And we have we don't observe any trend on young of the year and juveniles. These cohorts fluctuate a lot from a year to another, and that can explain that we could, over a 30 years period, any trends on these cohorts. So in conclusion, we suppose that the decline in adult trout density is likely due to multifactorial effects, including possible interacting factors. So it's not simple. We can study any factors. Our approach doesn't allow to quantify the role of each factor nor the relative share of their effect of trout density. So it's just hypothesis. And we need further study to identify precisely the causes and the multiple causes of the adult trout decline and the disparity between areas that that is a question that we don't have the issue for this question. And we need to maintain long-term fish monitoring. Here we have 30 years of fish sampling, so it's a large data set, but we have to maintain this and combine with extensive environmental monitoring to allow appropriate and efficient management measures. So it's finished for me. Thank you.